Hello everyone, welcome back to my channel Karthik Shiva World. Today I am going to explain you about normalization is the first topic, and then the terms related to normalization like data redundancy, data inconsistency, what is candidate key, what is prime attribute, what is non-prime attribute, okay, what are the data anomalies, okay. Then we'll go for first normal form, second normal form and third normal form, okay, how to normalize the data. Then we'll check the constraints, okay. So we'll discuss about the first topic, normalization, okay. What is normalization? Normalization is the process of organizing the data in a database by eliminating redundancy and inconsistent dependency, okay. So what is meant by data redundancy? Okay, data redundancy is having multiple copies of data in database, okay. For example, if a product is purchased by customer and the seller is entering the data into the database by mistake two times, product data and customer data two times, there will be two copies of data. That is one of the data redundancy. And one more thing is, whenever student is joined in the college, okay, and the college is having the database as student data and student marks data in the same table, okay. Whenever student is joined, marks won't be available. So what he will do, he will enter the student data first without having the marks data, that is one copy. And once the marks are available, he will be entering the one more column, that is one more data, okay. Here is data redundancy is there, two copies of student details data, okay. And is data inconsistency. Data inconsistency is having that same data in different formats in the different databases, okay. Example is, suppose I have one banking application, okay. Front end, the application view, web, okay, that is developing by one company like TCS, and the back end operations in SQL everything is developing by another company, suppose Cognizant, okay. So what TCS will do, whatever customer is entering the data, it will store in one table, okay, and it will give it to Cognizant. So here TCS is having one data format and Cognizant is having one data format, okay. So both should be consistent. Example I will explain clearly, like suppose take this data sheet in TCS, okay. I am having the customers, okay, customers table in TCS Cognizant. I have customers table, okay. Here TCS is giving all the customers data entering in the web application to Cognizant to do the back end operations further, like calculations, or it may be anything, okay. It is the front end, it's the back end, okay, both are maintaining. So here customer ID, customer name, columns, okay, customer name, date, Okay, same data I am having here, I am sending to Cognizant also. What is the customer ID is defined as data type? Here it is number, here it is varchar 2 of 50. Okay, date I declared as date, joining date. Here customer ID same thing I have defined, but customer name I am giving it as varchar 2 of 20. Date of joining as I am storing it as varchar 2 of 30. Okay, see here they are maintaining two data formats. What is the data type here for the name? Varchar 2 of 50 characters, here 20 characters. Suppose in the front end my name is 30 characters. Okay, whatever the customer is coming to bank, his name is 30 characters. And same thing if I send to Cognizant and if they try to insert into the customer table, okay, what will happen? That error will come. Varchar 2 of only 20 characters are there. So this is one of the data inconsistency. Different format. Here it is varchar 2 of 50. Here it is varchar 2 of 20. Here it is storing date as date format. Here it is storing as varchar 2 of 30. So these are data inconsistencies. So what they will do in projects in real time, whatever data is sending by TCS, first they will discuss about the data formats, how you are sending the data, in which formats. Send me your table structure. Okay, so it will send one table structure, customer table structure to Cognizant. So it will validate and check the feasibility. Okay, this is the feasibility we can do in the database. Okay, so they will discuss and they will come to one consistency, so that there will be no inconsistent data types between data. Okay, now I think you understood what is meant by data inconsistency. What is data inconsistency? Having data in different formats, same data in different formats in database. Okay, now next, what is candidate key? Okay, to discuss the normal forms we need to know these terms. Okay, what is meant by candidate key? Candidate key is nothing but which will uniquely identify the non-prime attribute. Now I will tell you, not candidate key is one of the keys in the table which will uniquely identify the whole data in the database row. Okay, what is the prime attribute? Okay, prime attribute is part of the candidate key. Okay, one table can have multiple candidate keys. Okay, then what is non-prime attribute? Non-prime attribute is with which we can't get the other data in the row. I will give an example. Here part, supplier, quantity and supplier country is there. Okay, quantity can't define any of the attributes. Quantity, by knowing the quantity I can't tell the supplier name, I can't tell the part name, I can't tell the supplier country. So quantity is non-prime attribute. Okay, and prime attributes, based on part and supplier data I can derive the quantity. Okay, and based on supplier I can derive the supplier country. So what are the prime attributes? supplier and part and supplier are candidate keys here, which will uniquely identify the data. Okay, non-prime attributes. Here non-prime attributes are quantity and supplier country. Okay, based on supplier country I can't derive the quantity, supplier and part. So what are the candidates keys here? Candidate key is part and supplier. Prime attributes are supplier, okay, and part, and quantity is non-prime attribute and supplier country is non-prime attribute. Okay, hope you understood. Next, and why we are normalizing the data? Okay, there are different type of data anomalies: updation, deletion and insertion anomalies. Okay, updation anomaly, as I already discussed in data redundancy, updation anomaly is nothing but whenever there are multiple copies in database, you are not updating one data and updating only one data. If there are two data in database for student, storing the student address, student name and marks, everything, and in one row we are updating the address and in the other row we are not updating the address, so there updation anomalies will come. Okay, we are not updating properly whole data. Okay, and the deletion anomalies are nothing but if suppose student data, course data and grade data, everything is available in one table only. So course, what all courses are available, they are not having separate table. Suppose if I want to delete course, there are different courses like BSc, BCom, everything. Suppose if I want to delete the BTech course, I'm not teaching BTech in that college, GU college, so I want to delete that. If I delete that, I will miss the students data also. Okay, there is dependency. Okay, this is called deletion anomalies. I am not able to delete the data. This is one of the deletion anomaly. Okay, and updation anomalies. Suppose college rank got changed, the college. Okay, but in this table there will be millions of students records. If the college rank has changed, I need to change all the rows, which will be performance issue. College rank in all the columns I need to change. That is one of the updation anomaly example. Okay, next, insertion anomalies. Suppose whenever student and say, take the same example, whenever students data I want to insert into this table, but as soon as student is joined in the college, I won't be having any grade for the student. Correct, any grade for the student. So what will I do? I will insert with null value, or I am not able to insert into the table until grade has come into this table. So these are updation, deletion and insertion anomalies. Okay, because of these, okay, data redundancy and data inconsistency and data anomalies, we are going for normalization. So what is first normal form? 1NF. Okay, first normal form is nothing but every attribute. What is meant by attribute? Attribute is nothing but columns in the table. Okay, take this example. This is student attribute, this is course attribute. So here first normal form states that every attribute will have atomic value which will be not splittable. Okay, we can't split that anymore. Okay, here if you see student and courses, Jane Smith is having course as databases comma mathematics, John Lipinski English literature and database. So two attributes are there, so it is not in first normal form. So what we can do, we can separate, we need to separate this data as, what can I do, I can insert control C, I can separate that data by giving here as mathematics one row. So I have separated the data, like Jane Smith has come 2 times with mathematics and database. Okay, mathematics and database. John Lipinski, okay, has come 2 times with English literature and databases. Dave Baer 2 times mathematics and English literature. So each attribute has atomic value. So this is in first normal form. Now each attribute has atomic value. Okay, what is meant by second normal form? To be in second normal form, it should be in first normal form. Okay, what is second normal form? The first condition is it should be in first normal form, and there will not the all the non-prime attributes. Okay, non-prime attributes will be fully functionally dependent on candidate key. Okay, candidate keys. Okay, that means there should not be any partial dependency. Okay, like if AB is candidate key and deriving C, B should not derive C. Okay, they should, or A should not derive C. Okay, so this is called partial dependency. So second normal form is nothing but there should not be any partial dependency. Every non-prime attribute will be fully functionally dependent on candidate keys or prime attributes. Okay, and it should be in first normal form. Let's go to the example. Here if you see, I have data for part, supplier, quantity and supplier country. Okay, here quantity can be derived from part and supplier. Okay, so what is the candidate key here? Part and supplier is the candidate key. Part comma supplier is candidate key. So part and supplier is deriving quantity and supplier country. But if you can see, supplier country can be derived from supplier also. Okay, supplier sorry, supplier, we can derive supplier country. What is there in this? A, if suppose it is part, A is part, P is supplier, okay, AB is deriving C, country, quantity and supplier quantity. These two are non-prime attributes. These are prime attributes. Prime attribute is part of candidate key. Okay, here prime attributes are part and supplier, and candidate key is part comma supplier. But supplier also deriving the supplier quantity. That means there is partial dependency between supplier and supplier country for supplier country. So what we should do for second normal form, we need to remove the partial dependency. So what I have done, I can put supplier and supplier country in some other table. Okay, supplier country in some other table and bike parts in some other table. So divide the table into multiple tables for being in second normal form. Okay, remove the partial dependency. So here if you can see in the first table, part and supplier is deriving quantity. Okay, quantity is fully functionally dependent on part and supplier. Okay, here in the second table also, supplier and supplier country I have separated into separate table, so that supplier country is fully dependent on supplier. Okay, this way these two are in second normal form. Okay, now go to third normal form. What is third normal form? Okay, third normal form is nothing but, what are the condition? It should be in second normal form, and every non-prime attribute should be fully functional dependent on candidate keys, and there should not be any transitive dependency. Okay, what is meant by transitive dependency? If X is deriving Y, okay, Y should not derive C. Y is deriving Z. Okay, suppose X is the candidate key, and if it is deriving Y, and Y should not derive Z. Okay, X is the prime attribute and candidate key, and it is deriving the non-prime attribute Y. This non-prime attribute is deriving another non-prime attribute Z. This is called transitive dependency. Let's go to the example for third normal form. Okay, I have taken the orders table. Okay, here order ID, order date, customer and customer email. Based on order ID, I can derive the date, I can derive the customer, I can derive the customer email. But based on date, I can't derive the anything. Based on customer, I can derive only customer email, but not order ID. Okay, and the date. So I am taking as order ID. Based on order ID is candidate key. Okay, based on order ID, I can get all the values. These are non-prime attributes. These are candidate key. Order ID as candidate key. So based on this order ID, I am deriving date, customer and customer email. But here if you see, based on order ID, I am deriving customer, and customer is again can derive customer email. This is called transitive. Prime attribute is deriving one non-prime attribute. Again, non-prime attribute is deriving another non-prime attribute. So what we should do for removing the transitive dependency, splitting the tables. Okay, order id, date and customer I have given in one, okay, one uh, table. Based on this name I can't derive order id. Okay, and based on date I can't derive order id, because in the same date I have so many orders, and same customer can buy so many orders. Okay, so I have given, and this transitive dependency I have split into two. So here prime attribute is fully dependent on non-prime attribute. Okay, and it is in second normal form also, there is no partial dependency. Okay, whenever one table has given, you should check whether there is atomic values in all the attributes, is there any partial dependency, and is there any transitive dependency. Based on that we need to divide into different tables or different columns. Okay, different rows. So hope you understood first normal form, second normal form and third normal form, and what are the definitions for data redundancy, data inconsistency. Data inconsistency I have explained with banking example, data redundancy with students data. Okay, inserting multiple copies in the database. Okay, and with null values, anything. Okay, updation, deletion and insertion anomalies. Okay, now we'll come to the constraints in the database. There are 5 types of constraints: primary key constraints, foreign key constraint, check constraint, not null constraint and default constraint. Okay, these are used for normalizing the data, and data will be in consistent format in database. Okay, so let's go to the first one, primary key. How we can, what is primary key? Okay, primary key is nothing but which can uniquely identify the data in the database. Okay, what is the difference between primary key and candidate key? There can be many candidate keys. Okay, one or more candidate keys in the table, but there should be only one primary key in table. Okay, and it should be unique and it should not be null. Okay, there is one more constraint, unique constraint. Okay, unique constraint is nothing but same as primary key, but only thing is unique constraint will allow null value. Okay, so first we'll see the primary key constraint. Go to the database. I am in database, disconnect and connect. How we can give the primary key? Okay, I have some sample table. Okay, with the primary key. Okay, I am giving primary key here, column, data type and primary key. Okay, we can derive like this also, or we can derive at the end also. Okay, constraint name. Okay, pk underscore user. Okay, constraint name, then constraint primary key of id. Okay, two ways you can derive the primary key. Okay, now execute this. Missing, right? Okay, comma is missing. As I have already told, in any language, each comma and separator, everything uh, will play important role. Okay, if we miss comma also, errors will come. Okay, so syntaxes are very important. So table user data with pk created. Now if table is not available, how we can add constraints? Okay, alter table, table name. Okay, okay, add constraint primary key of id. Add constraint, you can give constraint name also, user data user pk. Okay, this is constraint name. And how we can drop the constraint? Drop alter table name, drop constraint pk underscore user. Okay, let's execute this. Table user data with pk altered. Now we'll see, we'll describe the describe user data with pk. No primary key, only not null constraint is there. Okay, now I am adding using alter table command. Table altered. Now what is the system table for seeing the constraints? Okay, it is select star from all constraints, where table name equal to user data pk. Okay, if you can see, table is created with three constraints. Two are not null constraints. Constraint type it will give as c. C is not null, is not null, and p is primary key pk. P it will give as type as p. Okay, database will understand like that. Okay, they have derived system tables. Not null constraint they are giving c, and constraint type for primary key they are giving it as p. Okay, and indexes, if you see, whenever we create primary key, index will automatically generate. Okay, what is the index name here? User underscore pk. Okay, now I will show you the difference. I have inserted some data. Okay, in sit user, go to the tables. I have created two tables. User data without pk, select a star from user data without pk, and with primary key and without primary key I have created two tables. Then we'll see how the database is fetching the data, whether primary key is useful or not, if there are millions of data. Okay, okay, I have inserted count star. I will show count of star. 2000 records. I have inserted 2000 records into both the tables. Okay. Now we'll see how primary key is acting, where id equal to 1. Okay. How we can see the explain plan, how database is executed. Okay. Select this one, right click, explain, explain plan. What is the shortcut? F10. Also you can press. Okay. This is without PK. What is the cost it is taking? 5. Okay. Cost is 5. And here object name is user data without PK. Now we'll see this one with PK, where what is the primary key attribute? ID. Sorry. Now how to see the explain plan? Right click, explain, explain plan. Now what is the cost? 1. Earlier what is the cost? It is 5. Okay. You can see the difference. And here it is using unique scan. Primary key it is using. Okay. That's why it is showing less cost. Cost is 1. Here it is cost is 5 and it is scanning the table fully. Here it is scanning unique scan. Okay. Like this, if you have millions of data, okay, then the cost will be reduced. Okay, that will be more faster, performance will be more with the primary key. Okay, now I think primary key is understood. Now like this you can practice at home with the more data with primary key and without primary key. Check how it is acting. Okay, now we'll go to the foreign key constraint. Okay, foreign key. Okay, employee and department table. Okay, we will create, go to prod tables, employee and departments. I have 2 tables. Okay, employee has employee number, e-name, job, manager, hire date, com, sal and department number. Okay, and the department number I am referring in departments table. Okay, so there in the first video itself I explained you about how we can give the relation between 2 tables using foreign key. Okay, foreign key constraint. Okay, so what is the syntax? Constraint, constraint name, in departments. I will show you in SQL. Okay, this is the SQL departments table. Okay, this is the parent table and we need to create the primary key in this table. I have created department number as primary key. Okay, as we are seeing in the console, it is showing all the table spaces, everything. Okay, but while we are creating, we'll create the departments table. If you want I can show you again. Okay, this is departments table. foreign primary key department number. Okay, the parent table, sorry, departments already there now, so I'm giving departments practice P. Okay, and the child table is employee. So okay, we'll create from here only. I'm taking the columns from here. Okay, we can derive here. This is the child table. I will replace control R, replace this with null. Okay, replace all. Now prod dot employee. Okay, employee number, employee name, and here department number we need to give the foreign key, comma, we need to give it as how to add it, constraint name is fk underscore dept. What is the constraint name? Foreign key, call for which column? dept number inside brackets. Okay, dept number. Here we should give reference, right? Table reference. So the keyword is references, departments table, department number. Okay, foreign key. What is the syntax? Constraint name, foreign key of department number in this table, references, departments P, department number, parent table, department number. Okay, here I am giving it as P. Okay, now there is another keyword here, on delete cascade. Suppose I am deleting the department from the department table, then it will delete all the rows from the employee table corresponding to that department. Okay, I will show you. Okay, no worries, don't worry. Missing right parenthesis, comma, foreign, F-O-R-E-I-G-N, foreign key name. Okay, why this error has come? Because I have given wrong constraint, right? Constraint. Okay. Now create table employee P created. So there is a relation between department P and employee table P. Okay. Now insert some records into employee table and department P table. Okay. I will insert from already existing table. Okay, insert into departments. First which table we need to insert? Parent table. Okay, otherwise integrity constraint will come, as I have already explained in first class. Department P. Okay, what are the columns? Department number, comma, department name. Okay, values select star from, I am giving the already existing table departments. Missing expression departments. These are why this error is coming. Okay. Here, whenever we are giving select statement, this value statement should not be given. That's why the error has come. So I have inserted 3 rows. Okay. Now for insert statement, we need to commit it. Now same way, we will insert into employee table also. Okay. Select star from employee. Here, employee P. Delete. Let's try like this. Integrity constraint. Parent key not found. Why? We have inserted, right? Select star from department B. IT manager and CSC. Okay. Now what we are inserting into department employee table, we'll see what is there in this. Select star from employee. Departments 20, 30 and 10. Okay. In departments B also 1, 2, 3. Okay. What can we do? We can update. Okay. Update department B. Okay. Set DEPT underscore number equal to 10, where DEPT name equal to IT. Okay. What error has come? Because in employee table department number is different. Okay. So I am updating all the departments data. Okay. 10, 20 and 30. Okay. Here it is manager. It is CSC. Okay. Now update this DPT. What is the DPT number? Okay, there is no hyphen. Okay, updated. Okay, now commit. Now try to insert into the employee table. 15 rows inserted. Okay, like this, in the easy way you can insert using select statement. Okay, only for practicing, so I am inserting into all. I am using already existing table. Okay, foreign key I have defined here. Okay, now we will see. We have seen integrity constraint while inserting itself. We will see on delete cascade what it is. Okay, now if I try to delete from, what is the syntax for delete? Delete from departments P, where DEPT number equal to 10. I am deleting the 10th department. Okay. First we will see what is there in the employee P table. Okay. Okay. It has 15 rows with 10, 20, 30 department. Now if I delete from departments table, DEPT number. Okay. Now I have committed. Now if I check from employee P table, okay, now you can see all the 10th department's data is deleted from employee P table. Okay, so what does this mean? On delete cascade will do whatever parent table. If I delete rows from parent table, corresponding child table records also will get deleted. That is called on delete cascade. So now you understood what is meant by primary key. I have explained with performance. Okay, and foreign key with on delete cascade. Okay, what else is remaining? Check constraint and not null constraint and default constraint and unique constraint. Okay. Not null constraint is nothing but it won't allow the null values while we are inserting the data. Okay, as a homework you can practice this. Declare it as not null one column and try to insert the data as null. And check constraint is used to check the value. Okay, I can show you the syntaxes. Okay, constraints. Okay, what is for creating, what is for altering, and what is for dropping. Okay, for not null constraint, if table is already existing, then alter table persons modify age int not null. Okay, if while creating the table we can give in corresponding with column name. Okay, this you can do it as homework. Okay, alter table, modify. If I want to make it as null, okay, dropping the not null constraint. Okay, unique constraint same way as primary key constraint, the altering and dropping everything. Okay, primary key already explained, foreign key already explained. Check constraint, in the column name only we can give age is the column name greater than 18, or we can give in the alter table statement. Same like primary key, foreign key and unique key. These four keys syntaxes are similar, and default constraint and not null constraint syntaxes are similar. Okay, only difference will come in alter table and create table. Okay, for all other constraint name and the values. Okay, and some of the notes, you can have many unique constraints per table but only one primary key constraint. Okay, primary key can consist of single or multiple columns. Okay, primary key must contain unique values and cannot contain null values, but unique key can contain null values. Okay, primary key cannot be added on a view. Okay, view concept I have not explained it. While explaining that, I will explain this again. Okay, and you cannot delete or drop the index created by the primary key explicitly. Whenever the primary key is created, I have shown you, right, while executing or in the explain plan I have shown you. In all constraint, all underscore constraint system table also I have showed you an index is created. Okay, so that will be created. So that's all for today, guys. So what all we learned today? We have learned normal forms and normalization. Okay, what are the data anomalies occurs and how we are removing. Okay, using normal forms and using constraints. Okay, using constraints, how we are removing using primary key. We can't insert two rows again and again, so that multiple columns will not come. Okay, foreign key, we are splitting the table in primary key. Okay, splitting the table. Okay, check constraint used to check while inserting itself, it will check, the system will check. Okay, default values also we can give during the definition of the table, or after definition also you can add using alter table statements. Okay, and you can drop using alter table drop constraint. Okay, so hope you understood all the concepts today. If you need more examples and more detailed explanation, comment me, I can explain. Thank you for watching. If you like the concepts, please subscribe and give a like, share and subscribe, so that it will reach to more people and it will be more encouraging for me. Thank you guys. We'll see you in the next video. Bye bye.